In this video we're going to look at 1.7/1.8, talking about slope and constant rate of changes. For this video we're just going to do this front side of this page, and then we'll do the back side the next evening. Okay, so let's begin with our essential question. Our essential question is, how do I use slope and constant rate of change to understand the relationship between two variables. So what this means is we have two things, and how do they relate to one another. For instance, how fast you're running relates to how far you go in a set amount of time. The faster you're running, the farther you will go. So what we're trying to do is find that relationship between those two values. Um, so so that's what this whole question is talking about. But so the definition of constant rate of change is a rate of change is a rate that describes how one quantity changes in relation to another. So both quantities are changing, but how do they change kind of together? As one changes, the other will change. As you as you buy more pencils, you spend more money. So things like that. So all we have to do is this one example here on this page. So let's look at our example. A computer programmer charges customers per line of code written. Fill in the blanks with the amount of change between consecutive numbers. So if we get, for it to be a constant rate of change, we'd have to see that each change from the boxes on top are the same, and then we want all our boxes on the bottom to be the same. So from 50 to 100, how much does it change? It changes 50. Then from 100 to 150, to go from 100 to 150, you have to go another 50. Then from 150 to 200, we go another 50. Now we'll fill in our boxes along the bottom. 1,000 to 2,000, that's a change of 1,000. 2,000 to 3,000, that's another change of 1,000. And then 3,000 to 4,000 is another change of 1,000. So we have a constant rate of change because it's changing at a consistent rate in our numerator, in our top, 50, 50, and 50, and it's also changing consistently on our bottom. So these relationships are changing consistently together. So label the diagram below with the terms change in lines and change in dollars and constant rate of change. So if we're over here, we see that we have $1,000. Is that the change in lines, the change in dollars, or the constant rate of change? Well, that's our change in dollars. Here's our 1,000 right here, so we'll put change in dollars. Oops, sorry, I missed all that. Let me go over that again. So down here, what we're looking at is labeled a diagram below with the terms change in lines, change in dollars, and constant rate of change. So when we look at this $1,000, where do we see that consistent $1,000 happening? happening here. This is where that changing of 1,000 is. So that's our change in dollars. And then what's this 50 refer to? 50 lines. Well, that's our change in our lines of codes. That's our change in lines. And when we simplify this, dividing both top and bottom by 50, that's how we get 20 over 1, the $20 over one line. Remember finding our unit rate, dividing these two out? That's what we're doing right there. So the constant rate of change is $20 per line of programming code. So the constant rate of change is $20 per line of programming code. So what we're going to be doing is kind of diving into this a little bit more. So thank you for watching this video, and I hope you have a great rest of your day.